These are questions that may appear on the ACT or SAT. The old SAT or ACT rather, as of 2025, has 5 answer choices for math. Starting in April of 2025, only 4 choices. Digital SAT has 4 choices. These questions have 4 choices, but here's how to handle variables raised to fractional exponents, converting them into radical form. And there's some steps and there's a tip. Quick tip. Only variables with the numerator bigger than or equal to the denominator will be outside the radical. I need to put a space there. When converted to radical form. Eliminate answer choices with the wrong variables outside the radical. So this one doesn't have anything bigger, but there's no variables outside. That tip means nothing. Next, change the fractions to have common denominators. There's only one fraction there. The denominator is the root. The numerator is the power. So this is the 4th root. Let me get a pen here. The 4th root, and the numerator is the power, x to the 3rd power. And that is answer C. That one's done. Here's the second one. Again, the numerator not bigger than the denominator. There shouldn't be a y outside of the radical. There's only y, so there's only one fraction. It's got a common denominator 5. The denominator is the root, so this is the 5th root. Well, only b has the 5th root. Next one. Now I've got 2 fractions, x and y. Neither one has a numerator bigger than denominator, so nothing should be outside the radical. That means a is out, b is out. It could be c or d. Common denominator, yes. So the denominator is the root. And then keep the powers, y to the 1st, or just y, x cubed y. That is b. C has so much going on wrong. It's got the wrong root, the wrong powers inside the root. Number 4. For all positive x and y, x to the 2/5, y to the 1/5 can be rewritten in which of the following radical forms? Well, again, the denominators are the same. I've got no numerators bigger than denominators, so there shouldn't be x or y outside, so only a is the answer. Test A, pick A. But I'm going to go further just to finish it. Just for practice, the root is 5th, and it's x squared, y to the 1st, or just y, which, again, is A. Next one. For all positive x and y, x to the 1/3, y to the 5/3 can be written in which following radical forms? The denominators are the same, so it's common denominators. Y has a numerator bigger than denominator, x does not, so there should be a y outside and no x. D has an x outside and a y, but that x shouldn't be there. So now could it only be A, B, or C? Well, let me finish it. The root is 5, it's x, y, or root is 3 rather, xy to the 5th. Now, the rest of these steps. For each variable, subtract the root from the power. Each time this is done, 1, first power of that variable, goes outside the radical. Only do this if the exponent is bigger or the same as the root. Do this until you can no longer subtract the root from the power to leave a positive integer power or 0. If it's 0, that variable will not be inside the radical because anything to the 0 power equals 1. And then count the number of the same variable outside the radical. Write that variable to that power. Leave the variable with the remaining power inside the radical. So x, the first power is smaller than 3, but 5 is bigger. So 5 minus 3 is 2. And I'll write a y outside there. 2 is not bigger than 3 now, so can't do any more. Y, inside is the cube root, is x, y squared. And that is, that I wrote it so that, hold on, let me erase that. I wrote it so it looks like the power of y is 3. The power of y is in 3. The root is 3. So be clear in my writing. And that would be answer B. Number 6. X to the 4/5, y to the 5/3. Only y has a numerator bigger than denominator, so there should be a y outside but no x. No y outside, no y outside. X is outside, shouldn't be. So the answer has to be C, but I'll finish it just for practice. The common denominator is 15. It's got to be the least common denominator. I wrote 30, I'd get the wrong exponents. So 15, I get the wrong exponents and I'd have the wrong root. It's got to be the least common denominator. So 15, 5 goes into 15 3 times 4 is 12, x to the 12 fifteenths. Y, 3 goes into 15 5 times 5 is 25 fifteenths. 15 is the root, x to the 12th, y to the 25th. Now, 12 isn't bigger than 15, but 25 is. 25 minus 15 is 10. I'll put a y outside. And 10 is not bigger than 15, can't do any more. So this is y times the 15th root of x to the 12th, y to the 10th. And verifies that C is the answer on test day. No reason to do all that because only one had the right variable outside the radical. Next one, x to the 4 thirds, I almost said 4 turds, y to the 5/8. Only x has a numerator bigger than the denominator, so there has to be an x and only an x outside. A does not have an x, C has a y but no x, and D has x and y, so the answer has to be B. I will finish it for practice. The common denominator is 24. 3 goes into 24, 8. 8 times 4 is 32. And then y, 8 goes into 24, 3. 3 times 5 is 15. And now the root is 24. X, 32. Y to the 15th. 15 is too small. Can't subtract 24 from it and have a positive integer, so leave it. 32 minus 24 is 8. Put an x outside. Can't subtract anymore, so it's x times the 24th root of x to the 8th, y to the 5th. Verifies that the answer is B. Wouldn't have to do that on test day, though, because only B had the correct variable outside. 8x to the 3/5, y to the 9/4. Only y has the numerator bigger than denominator. A does not have a y outside, B does not, C does. D has an x, which shouldn't be outside because its numerator is smaller than denominator, so C is the answer. I will finish it for practice. The common denominator is 20. 5 goes into 20 4 times. 4 times 3 is 12. X to the 12 over 20. Y, 4 goes into 25 times. 5 times 9 is 45. On test day, I wouldn't be doing any of this because I've already got the answer, just based on which one had a bigger denominator than numerator, only y. So only y went outside, but I'm doing this for practice. So the root is 20, x to the 12th, y to the 45th. 12 is not bigger than 20, but 45 is. 45 minus 20 is 25. So I put a y outside. 25 is bigger than 20. 25 minus 20 is 5, another y. And that's it. 5 isn't bigger than 20. 2 y's, that's y squared. Square root, x to the 12th, y to the 5th. Verified. I wouldn't have to do that on test day, though. I used the quick tip to get the answer on test day. xy to the 3/5. That's 1 over 1. So I'm just writing it in there. Common denominator is 5. This is x to the 5 over 5. 1 goes into 5 times. 5 times 1 is 5. Y to the 3/5. So now, before I do that, only x has a exponent with numerator and denominator equal. The numerator has to be bigger than the denominator or equal to have that variable outside the radical when it's in radical form. Y, the numerator, is smaller. So only x should be outside, and it has to be x. So this one's out. B has an x. C has only a y. And D. So the answer could be B or D. I got a 50-50 shot. All right, I'm going to continue. 5 is the root. I'll write x to the 5th, y to the 3rd. They're equal, so 5 minus 5 is 0. I can put an x outside. X to the 0 is just 1, so it goes away. 3 is not bigger, so it's x, 5th root of y cubed. So it's B. What's wrong with C? C has still an x inside. And then number 10, x to the 4/3, y to the 3/2 must have x and y outside of the radical. A does not, B does not, C and D do. 50-50 shot. 3 and 2, the common denominator is 6. 3 goes into 6 twice. 2 times 4 is 8. X to the 8/6. Y, 2 goes into 6 3 times. 2 times 3 is 9. 9/6. The root is 6. X to the 8th. Y to the 9th. 8 is bigger than 6. So 8 minus 6 is 2. I'll put an x outside. And now 2 is smaller than 6. 9 minus 6 is 3. I'll put a y outside. 3 is now smaller than 6. So I can't do anything more. It's xy, the 6th root of x squared y cubed. And which one is it? This one. This one just used the original, I think it used the original numerators. So that's what's wrong with D. But anyway, the answer is C. So there's a little practice with variables they're called rational exponents, exponents that are fractions, and converting them to radical form. Could help you on ACT or SAT.